Okay, we went through that last acid equilibrium problem very quickly. I just wanted to explain the layout. I think you'll understand it much better as we build it. I'm going to skip this one. I'm only going to do one of these for you, but I want to give you the answers. This is 2.17 for the pH, and the percent ionization is 0.268%. Instead, I want to go on to the next one. We have hypochlorous acid. Hypochlorous is HClO. Now, if you've forgotten your acid names, just do the best you can and keep going with the problem, and you will likely get at least some really good partial credit. Now, remember, what does an acid do best? An acid donates an H+. Now the Ka is going to be products H+ over ClO-, or if you prefer, you can put H3O+. That's acceptable, in fact preferable. I wish I would get into the habit, and I'm just not. Okay, divided by, so it's always products on top, reactants on the bottom. So this grid here is to provide you with your framework for problem solving. And then we'll do our work down in this space. Now the percent ionization is the H+ that forms at equilibrium divided by, so if you want to put a little EQ there to emphasize that, divided by my initial acid concentration times 100. So if you can get this down, you're a long way towards providing yourself with a good framework for the problem solving activity. Now I have a 1.0 molar solution. Initially, there are no other sources of H+ or ClO- other than the equilibrium we're dealing with. Now, if this was a stoichiometry, I would lose all of this 1.0, but it's not. I'm going to lose an unknown amount, minus A. Since it's a 1-to-1 mole ratio, I'm going to gain A. And again, it's a 1-to-1, and I'm going to quit doing that because this whole section is 1-to-1. So then I get 1.0 minus A, and A. Now you have to look up your Ka values. Those are provided for you on tables, or they will be given in the context of the problem. And I get 3.0 times 10 to the minus 8th for my hypochlorous acid. And I've got A for my H+ times A for my HClO-. Remember, I'm taking what's given in this last equilibrium constant column and putting it into the equilibrium constant over 1.0 molar. Now, if I do my algebra, I do have to take the square root. A would equal then the square root of 3 times 10 to the minus 8th, and A is equal to 1.73 times 10 to the minus 4th. Molar, be careful. K doesn't have units, but your concentrations do, and you will lose points if you forget them. Now, I want to redefine that for us. Remember, A, it's equal to both ion concentrations, but in particular, it's equal to my H+ concentration. Now, if you have A, it's only one step to pH, because pH is equal to minus the log of your H+, 1.73 times 10 to the minus 4th. And when you plug that in, you all did quite well on that. There shouldn't be a problem. And if there is, I want you to come and see me. So my pH is 3.76. Now, what about my percent ionization? My percent ionization is equal to my H+ at equilibrium, which is what I solved here. Remember, it's my H+ at equilibrium. So it's 1.73 times 10 to the minus 4th over my original H+, which is 1.0 times 100. So in this case, our percent ionization is 1.73 times 10 to the minus 2%. Tiny, tiny, tiny percent. this favors staying together in the HClO form much, much more than it does donating that H plus to, actually you're donating it to the water to form H3O plus, or freeing up that H3O plus. Now, which is stronger? Well, Ka for the acetic acid was equal to 1.8 times 10 to the minus fifth. My Ka for my hypochlorous was 3 so for my HClO, 3.0 times 10 to the minus eighth. Now, let's evaluate this. As I increase Ka, I increase my concentration of products overall because products are in the numerator. That means I increase the percent dissociation or ionization. And that means we recall that then an increase in the strength of the acid. Now, both of these are weak acids, but of the two, acetic acid is the stronger. Okay, so that's how you do a Ka problem. In the next video, I will show you how to do a Kb problem. So until then, this is your best chem teacher signing off.